welcome to the February edition of the 2024 NRCS Conservation Outcomes webinar series. My name is Laura Crowell, and I am a Natural Resources Communications Specialist with the USDA Natural Resources Conservation Service, or NRCS. We host this webinar series to provide key findings, data, and tools to support farmers and ranchers, other land managers, conservation partners, members of academia, and other researchers in pursuing voluntary conservation efforts across the nation. We will get started with today's presentation in just a moment. First, a few logistics. If you would like to receive email notifications with information on upcoming webinars, please subscribe to the NRCS Conservation Outcomes topic via GovDelivery. You may do so by following the instructions on the screen. A direct link to access the GovDelivery subscription webpage will be available in the meeting chat and is provided at the top of the NRCS Conservation Outcomes webinar series webpage. If you're having problems with audio, sometimes computer or mobile device headsets can help. It may also help to leave and re-enter this webinar session. You may access live captions during this webinar by clicking the three dots with the word "More" on the meeting screen. This will enable you to turn on the Turn on Live Captions function. We will momentarily post additional links and resources in the meeting chat. One important resource is our Conservation Outcomes webinar series webpage. That URL is nrcs.usda.gov/conservation-outcomes-webinar, and it currently is displayed. This is where you can find resources from today's event, the recording of this webinar, and the presentation slides will be posted to this webpage by mid-March. Finally, we encourage everyone to type questions or comments into the chat throughout today's presentation. We will address as many of your questions as we can during a Q&A session at the end of the event. If we do not get to your question or you have follow-up thoughts, please email me at laura.crowell@usda.gov. With that, it's time to get started. It's a true honor and privilege to introduce our Colorado State Conservationist, Clint Evans. Thank you for joining us today.
Hey, good afternoon, Laura. Good afternoon, everyone, and welcome to the February edition of our Conservation Outcomes webinar series. Thank you for taking time to join us today. At the USDA's Natural Resources Conservation Service, one of our driving missions is working with agricultural producers, including ranchers and other land managers, to strengthen their operations and conserve natural resources through voluntary efforts. As USDA's primary private lands conservation agency, we generate, manage, and share the data, technology, and standards that enable landowners and our many conservation partners to make decisions informed by objective and reliable science. USDA's Conservation Effects Assessment Project, or CEAP, is a multi-agency effort led by the Natural Resources Conservation Service to quantify the effects of conservation outcomes and support data-driven conservation decisions across the nation's working lands. CEAP works closely with our science partners and other federal agencies, members of academia, and partners here at the USDA, such as our colleagues with the University of Arizona and Earth Economics. Findings from these collaborative efforts inform improved conservation delivery for the NRCS and strengthen management decisions across working lands nationwide. Our Conservation Outcomes webinar series enables us to directly communicate with all of you, our conservation and research partners and colleagues, agricultural producers, other private landowners, and land managers on the documented outcomes associated with this work. Today's webinar will highlight an important effort that helps NRCS staff, land managers, and others account for the value of ecosystem services, like the air quality and increased water infiltration provided by Rangeland Conservation Practices. This work is important because understanding these values empowers our conservation planning staff to provide the best possible advice when working with landowners. It allows us to make recommendations that delivers the most bang for the buck for our customers. And it also helps make our customers evaluate alternatives and make decisions for their operations. The CEAP project featured in today's webinar used an evolving framework that links conservation practices to their impacts on nature, and is focused on brush management, herbaceous weed treatment, prescribed grazing, and a collection of 13 ecosystem service benefits that they provide. The project area included the state of Colorado and 10 other states in the Western Range and Irrigated region. Over the years, the science around ecosystem services has been building and improving rapidly. In fact, this project is the second using this framework co-produced by Earth Economics and CEAP Grazing Lands. In 2020, a report was produced for the Central Great Plains that valued 12 ecosystem services when brush management and prescribed grazing were applied to non-federal lands. This effort in the Western Range and Irrigated region expands on the work in the Central Great Plains. One particular example of this being applied at the local level is the Lesser Prairie Chicken Landowners Alliance. They're a producer-driven organization that works to implement ecosystem services to improve rangeland habitat, as well as habitat for lesser prairie chicken and other critical wildlife species. Thank you again for joining us today. Now I'd like to turn it over to Carrie Ann Howdyshell, our CEAP Grazing Lands co-lead, to provide the details on this webinar and introduce our guest presenters. Thank you.
Great. Thank you, Clint. The NRCS CEAP grazing land effort started in 2006, and since that time, we have strived to quantify the effects of voluntary conservation efforts across the nation's non-federal, that is private, state, local, and tribal grazing lands, as well as our federally managed rangelands in partnership with the Bureau of Land Management. Thank you for joining us today. I'm excited to share some insights from a new co-produced study that accounts for the ecosystem services provided by Rangeland Conservation Practices in key Western states. Outcomes from this study are outlined in our report titled Accounting for Nature's Value with Rangeland Conservation Practices in the Western Range and Irrigated region. It's released with Earth Economics and our partners from the University of Arizona. The report and past grazing land assessment efforts, reports, and other documents can be found on the CEAP webpage as well as the CEAP Grazing Land webpage, both of which links are included in today's lists. I'd like to introduce now our two speakers, Dr. Lien and Angela Fletcher. Dr. Lien is an assistant professor of rangeland ecology and adaptive management in the School of Natural Resources for the University of Arizona. He has worked on several projects that focus on economic incentives in conservation and the valuation of ecosystem services. Angela Fletcher is a senior researcher and tools and data manager for Earth Economics. She is the lead author of both the Ecosystem Services Valuation Report we're discussing today, as well as the 2020 report that Clint referred to earlier. She is the manager of Earth Economics Ecosystem Valuation Toolkit and has produced many reports for federal and state agencies giving value to nature's benefits. So I'll pass it over to Dr. Lien now for the main webinar presentation, but I'll be back at the end for the Q&A session. Aaron.
Thank you, Carrie Ann. Just working on getting my presentation shared here. Great. Well, thank you, Carrie Ann. I'm very happy to be here and to be able to participate in the Conservation Outcomes webinar to present the results of our work to measure and quantify the ecosystem service values associated with NRCS conservation investments on Western rangelands. I'm going to give a brief introduction to our work and give some background about the project's goals and study area and ecosystem services in general. And then I'm going to turn it over to Angela, who will go much more in depth into the work that was conducted as a part of this project, go through the methods of how we determined the ecosystem service values associated with the conservation practices that we reviewed, and give you some more detailed results than what I provide in this brief introduction. So just to give you an idea of how the order of operations will go through my presentation and Angela's presentation, I'll start by giving an overview, discuss some of our main results and outcomes and some initial implications, and then I will turn it over to Angela, who will give a detailed review of the project and its results and dive more into those outcomes and implications, and then we will have some time at the end for questions and discussion. So why are we doing this work? What hole is this filling in our knowledge? Well, one of the things that we don't know as well as we might hope that we would is what is the value of conservation investments in terms of the benefits that we receive from implementing conservation practices on rangelands and other agricultural lands. The NRCS invests significant amounts of taxpayer money each year into conservation programs, conservation practices, working with producers. And by conducting ecosystem service valuation, we can get a better understanding of what the values of those investments are for both the producers and for others who benefit from these ecosystem services. By doing this work, we can support more informed decision-making about resource allocation, so where we invest in conservation practices, which conservation practices we might choose to fund more or less as a result of the larger benefits received by society. It helps us balance agricultural productivity and ecosystem health. We can easily measure the outcomes of agricultural productivity through market value of the agricultural products that are produced, but it is more difficult to value those ecosystem health components. And so by valuing our ecosystem services, we can start to get a better sense of the benefits of our investments in conservation practices for those ecosystem health outcomes that support our larger agricultural system as well as other systems throughout the country. This also helps us account for unrecognized and intangible benefits of conservation. So just as we can recognize the economic outcomes of agricultural productivity, we can similarly recognize that there are economic benefits to ecosystem health investments and investments in conservation practices. So by going through this process of valuing ecosystem services, we can understand where we're getting direct benefits from conservation for people on farms and off of farms, and what those values are to the American people. And then ultimately, this goes to help to support outcomes-based decision-making. So we can make better decisions about what we invest in and where we place our conservation investments based on what we expect to get from those investments, rather than simply looking at what the practices themselves are and where they can be applied on the landscape. So our primary goal in this project then was to provide an estimate of the economic value of ecosystem services associated with certain rangeland conservation practices. And specifically, we looked at 3 conservation practices in this work. We looked at prescribed grazing, brush management, and herbaceous weed treatments. These were practices where we have a good deal of data available for estimating ecosystem service outcomes, and we also have economic data available to be able to value those ecosystem services. For each of these practices, we looked at a suite of 13 ecosystem services, and I'll review what those 13 ecosystem services are in a few minutes here. First, to give you an idea of where this project took place. So this was focused on Land Resource Region D. So this is much of the southwestern United States, the Great Basin, and other parts of the Intermountain West. So this includes all of or parts of 11 states, 23 MLRAs. It also includes, BLM rangelands, Forest Service rangelands, as well as non-federal rangelands or private lands. And so on the map here, the blue lands are non-federal rangelands, and the yellow is BLM rangelands. So what are ecosystem services? What do we mean when we talk about ecosystem services? Well, we can start by thinking about three different components that make up this idea of ecosystem services. The first thing to think about is natural capital. And so natural capital is the total endowment that we receive from natural systems and that benefits people and human societies, right? So this is the combination of all of the ecosystem function, all of the ecosystem goods and services that we receive from these natural systems. And when taken together, that is the total natural capital. And then we can break that natural capital down into a couple of different components. So we can think about ecosystem function. And so that ecosystem function is how ecosystems work to ultimately produce ecosystem services. So when precipitation falls on a grassland, that water moves through the grassland in different ways based on the ecological function of that grassland, what sorts of grasses are present, the amount of bare soil, the amount of leaf litter, all of these different factors that fit together into a functioning ecosystem, and that helps to determine how that precipitation moves through the system and can result in ecosystem services of greater value, lesser value, or greater quantity or lesser quantity, depending on that ecosystem function. So as that precipitation moves through that grassland, it may get filtered by the soils and producing clean water when it reaches the stream. And so that clean water is the ecosystem service that we're receiving from that grassland. Could also be flood control benefits or many other types of benefits that we receive from rangelands. And so we can add up these ecosystem functions and the resulting ecosystem services to understand the total natural capital that we're receiving from natural systems. There's many ways to look at this kind of total natural capital and the individual ecosystem services that we're receiving from natural systems. And so this figure is from a science article that was published about 15 or so years ago now. And it's showing what sort of ecosystem services we might expect to get from different land uses. So in a natural ecosystem, we get lots of ecosystem services in terms of habitat and forest production, climate regulation, but we don't get crop production. In intensive cropland, we get lots of crop production, but our other ecosystem service benefits might be reduced. And then in agroecosystem, kind of an integrated crop and natural system, we might be able to find a balance between agricultural production and ecosystem services that are provided for other benefits, like regulating the climate and providing habitat for wildlife. And so by investing in conservation practices, this is one of the things that we are trying to achieve, trying to increase those ecosystem services received from productive agricultural lands while also maintaining those benefits in terms of agricultural production that we receive from these landscapes. There are really two different categories of ecosystem services. There are those ecosystem services that we can easily understand the values of because they are a part of our economy already. So things like forage that livestock eat, we have a sense of what the value of that forage is. We have a sense of what the value of a calf is when it goes to the auction to be sold, and that's a result of grazing on that forage and utilizing that natural ecosystem. So we have those market values for certain ecosystem services, but there are many ecosystem services, such as wildlife habitat, where there's no market, where those services are not bought or sold, and so valuing them is much more difficult. So in order to value these non-market benefits, these non-market ecosystem services, we need to look to other methods. We need to think about how people value these services through their contingent valuation and other sorts of methods to understand in non-market conditions, how people value these services. And it's this second category that we were focused on in our work here. So how do people value these non-market benefits that they're receiving from the implementation of conservation incentive practices? The 13 specific ecosystem services that we looked at in this study are listed here. So we are looking at a wide range of ecosystem services, ranging from cultural services like aesthetics and the role of ecosystems and kind of satisfaction in humans' lives, to soil fertility and carbon sequestration. So there's many different ecosystem services that are provided by rangeland systems and by implementation of conservation practices. So we're looking at a wide range here to try to understand the totality of the value of these conservation practices. This is also something that the federal government is very interested in understanding. So there are many policies in place at this point on providing either guidance on how to go about valuing ecosystem services or encouraging agencies to think about the value of ecosystem services in their work. And these are just some of them. And so this work helps to fulfill some of the intention of these policies. And so to give you a snapshot of the results of our study, and Angela is going to go into this in much more detail, but I'm just providing the snapshot here now so you can keep this in mind as we hear from Angela about the specifics of how we went about arriving at these values and some of the nuance in these values. So you can kind of keep this in mind as you're listening to her talk. We estimated the total ecosystem service values for each of these three practices on a per acre per year benefit, per acre per year basis. And you can see the results here. So for NRCS funded practices, so these are primarily on private lands, we have a range here from prescribed grazing at kind of the low end of $2 to $5 per acre per year, and on herbaceous weed treatment up to the high end there of up to $26 per acre per year. And then on BLM lands, on federal rangelands, we have similar but somewhat different values there that are reflecting the different uses of those lands and the different benefits that are received on those federal lands versus on the private lands. So keep these values in mind as you're listening to Angela's talk and how we went about deriving these values. Hopefully, by keeping that in mind, it will help to crystallize some of those methods that she's talking about, help them make a little bit more sense or easier to grasp as she's talking through them. So why does all of this matter? What are the implications of this work? Well, the first thing is it helps us understand that conservation investments do matter, right? They are improving ecosystem service values, and there is a direct benefit to producers and others from these conservation investments. So those investments are worthwhile for taxpayers. There's a value to those benefits, and they are resulting in meaningful change over time. We are seeing improvement in ecosystem services in agricultural landscapes. It's important to keep in mind that the actual impacts of NRCS programs are much greater than what we are seeing in the numbers here. So we have significant gaps in data that allow us to only value certain management practices and also only allow us to value certain ecosystem services. And we're limited in our ability to understand the real total value of even these three practices that we looked at. So if we were able to understand all of the ecosystem services that these practices provided and the total value of those ecosystem services, it's very likely that the values that came out of this work would be higher. And so that leads to the third implication. We really need more data to better estimate the impacts of conservation investments on ecosystem services and those benefits to producers and to society as a whole. So better monitoring of practice implementation and outcomes so that we have a better sense of the ecosystem services that are being provided by conservation practices, and then more research to link ecosystem service outcomes to economic values, so we can conduct this sort of valuation work and provide a more tangible way of thinking about the value of conservation investments for the general public and for producers. So with that, I'm going to turn it over to Angela, who will provide a much more detailed look at the work and the methods that were used to come up with those ecosystem service values.
Thanks, Aaron. Great. So I want to start out with just some additional context around our project goals, which will help explain why we set up the project as we did. So our vision is to help agencies include ecosystem service values into their processes. These conservation programs typically are huge, so we wanted to think about how we could tailor this framework to help account for those benefits at scale. This means our goal was more to provide a broad sense of what those benefits could be in dollar terms, and also help reveal gaps in the existing science as a way to inform research priorities. So as we said, the particular results I'm presenting today are actually the second iteration of this project framework. Our first project looked at conservation benefits in the Central Great Plains. Here we're looking at the Southwest, specifically the NRCS Western Range and Irrigated region, or LRRD. As Aaron mentioned, in this project, we're looking at both non-federal rangelands that NRCS provides support to, and also BLM managed rangelands. I mentioned that we wanted to quantify these benefits at scale, which provided some unique challenges in how we set up our analysis. So thinking of NRCS, they support conservation throughout the country through financial assistance contracts. Pretty basic set of information, which is restricted further to protect producer confidentiality. So this all means what we really knew for each contract was what practices were applied, when it was done, what MLRA it was done in, and how many acres of rangeland were treated. We also want results to be available quickly and to be easily updated every year. So repeatability is a big concern. And these practices are also being applied on very different landscapes throughout the country. So we want any underlying data that we use to be available across those different locations. This all means that we ended up relying pretty heavily on already published data, things the agencies have collected, and scientific literature. So there's 5 main steps to the framework that we used. I'll go through these in more detail, but just give a quick summary of the overall flow right now. So first, we need to determine what practices are being applied on rangelands in our study area and how often they're being applied. Next, we need to figure out the starting point for the metrics we're going to use. In other words, the condition of the study area before practices were applied in our study period. Once we have that baseline, we can determine where specifically the practices are being applied, and then what the size of the effect will be on our selected metrics. Finally, we want to translate all those effects into dollar values of ecosystem service benefits. So first on the actions, we used NRCS contract data for practices that were certified on rangelands in LRRD from 2011 to 2020. In addition, for this second application of the framework, we wanted to demonstrate its potential to assess other agency data as well. So we included BLM treatments from the Land Treatment Digital Library from 2016 to 2020. And BLM is also one of the biggest landowners in the region as well. Due to gaps in the literature, which I'll get into a little bit later, we focused on the 3 most implemented practices in LRRD. So that's brush management, prescribed grazing, and herbaceous weed treatment. Herbaceous weed treatment was also not included in the first report, but the other 2 were. So keep in mind that all results that we'll present on are only for these 3 practices. So next, we considered 3 aspects to construct our baseline. First, the land cover types of rangeland, the productivity or health of the land in providing ecosystem services, and the initial monetary values of ecosystem services. So first, we looked at the different land cover types that make up rangeland in the area using GIS data. This is important because different land cover types like forest, grasslands, and shrublands can provide very different levels of ecosystem services. And the NRCS definition for rangeland, for example, does include these different land cover types. So first, we identified what lands were considered rangeland with a data layer from the Forest Service. Then we mapped the National Land Cover Database types onto that, focusing on those 3 land cover types, forest, grass, and shrub, since those were the ones that are most likely to be grazed in this area. So another key component to the baseline is the use of rangeland health data to indicate the direction and magnitude of changes to land health when conservation practices are implemented. Since we wanted the framework to be adaptable wherever agencies are implementing these practices, we wanted any of that underlying data about range health to be accessible and comparable in these different locations. So we know through the NRI and AIM projects, these data exist across the US and they're estimated consistently. In addition, they have very similar methodologies, so the framework can be applied to multiple agencies rather than just being NRCS specific. So we limited our use of baseline data to the years preceding the first year of analysis. This provided a sufficient sample size for our baseline data and also factored in any incremental improvements in rangeland health due to practices applied in those baseline years. So the table here shows the 17 rangeland health indicators that, when they're combined as shown by the colors in each column, provide the final attribute ratings. So we normalized these attribute ratings on a numerical index and took the weighted average of all points within an MLRA to derive a health score for each MLRA in LRRD. So this graph is showing the results of that analysis. The box plots show the variation in the average MLRA scores. So a 1 represents no departure from reference conditions, so a healthy rangeland. And scores closer to 0 represent larger departures from reference conditions, representing unhealthy rangelands. So in LRRD, rangelands tended to be pretty healthy overall. They generally had scores of above 0.7. BLM managed rangelands were slightly lower, which we speculate could be due to the mixed use nature of those lands. But overall, these scores tell us what we need to work on first. So biotic integrity issues, followed by hydrologic function concerns, followed by soil conditions. So as ranchers work with agencies to improve these attributes, the value of ecosystem goods and services should also improve, which leads us to the next part of the baseline, which was estimating the starting value for what rangelands provide in terms of ecosystem services before practices were applied in the study area. So we found that because of the constraints that we faced for our framework, our best solution was to use the benefit transfer method to value ecosystem services. Benefit transfer can be described simply as applying research results in a setting other than the one it was originally collected for. It sounds simple, but there's a lot of best practices outlined in the literature for how to properly select studies for transfer. And you can read all about the criteria we used to select studies in the report. But benefit transfer is a common and accepted method used to produce actionable results, and it's used by other federal agencies in decision-making too. So for example, FEMA uses benefit transfer to include ecosystem service values in their benefit cost tool for disaster recovery and mitigation. And there's other examples out there too. But it's specifically useful for our framework because LRRD is huge, it's millions of acres. It would be impossible for us to do primary evaluations at every site where a conservation practice is being implemented. So for this iteration of the framework and following some comments we received on the first round, we used both point estimates, so those estimated as just an average or range per unit, and function transfer estimates, in which we take models estimated in the literature and derive a customized unit value for our study site. And this is generally accepted to produce less error when transferring values as well. So values came mostly from studies conducted in the southwest of the US in LRRD and from one global meta-analysis of grassland ecosystem services that we used function transfer with. In the final dataset, we selected a total of 34 value estimates from 16 studies on grassland, shrubland, and forest ecosystem services to use in this framework, and that covered 13 different ecosystem services. The table shown on this slide indicates which services were valued on each land cover type with dots. As you can see, there's a lot of gaps in the table, and common frameworks of ecosystem services can include up to 23 services in total, so 10 more than even what we have valued here. However, I just want to stress that these gaps don't mean that the services aren't valuable or they're not provided, only that we lacked appropriate literature to apply them to our study area. And since we found relatively few studies, most of these dots represent estimates from just one or two of those studies in our data set. And that's why we focused on literature conducted in our study area or literature that could be tailored to our study area. So the next few charts show the range and average of the values that we used in the data set. Here we can see habitat, soil fertility, and waste treatment were the highest values on grasslands. On shrubland, carbon sequestration had the highest values, followed by recreation, which also had the highest range in values. And for forests, we transferred the least amount of values, but it had the highest per acre values overall of the land cover types. And it also had the highest variation in values, as you can see, for water supply and carbon sequestration. So for carbon, that had to do with estimates for different age classes and the data we were using. And for water supply, it had to do with the different water users that were included in the study, so whether they were municipal, industrial, or residential. Finally, we wanted to tie those dollar values to our estimates of rangeland health, since we expect that as ecosystem health degrades, the ability to provide ecosystem services also declines. Following some previous work, we assumed a linear response of service values to the health index that we estimated. Essentially, we're discounting those dollar values by the health attribute scores achieved in each MLRA. Unfortunately, there's little supporting research at this time to support any other specification here. And our thinking is that at least the linear rate provides a reasonable average among all possible relationships. It also assumes that the values from the literature are for pristine locations, which many are, but a significant amount of studies also don't have any information about ecosystem function in them. So we felt that this is also a conservative assumption to make. So after we estimate the baseline, our treatment data contains the extent of those areas being treated. So for NRCS, it's more general. We know some amount of acres was treated in an MLRA. So we converted the rangeland areas treated to specific land cover types using the average proportions of the land cover types in each MLRA. But for BLM, we have shapefiles for all of the treatments, so we know specifically where they were done. So we can overlay those onto NLCD data to know what types of land covers were actually treated. Next, we have to determine the magnitude and direction of change on the land from practices being applied. Here again, we turn to literature reviews to accomplish this, to compile a database of literature that links practice application to changes in metrics of those rangeland health indices. This was done with the Conservation Outcomes Research Explorer database, referred to as CORE, which is a database of peer-reviewed published journal articles and reports reviewed by our CEAP grazing lands partners as part of this work. Any research that was entered into CORE for this study had to meet two main criteria. First, it had to be clear that the field work or treatments and data collection reflected standards and guidelines for an NRCS conservation practice. And 2, the paper had to have measurable data so that actual differences from beginning to the end of the study could be calculated. Lastly, the measured data was linked to one of the 3 rangeland health attributes found in the interpreting indicators of rangeland health. So from each study, we recorded the practices being applied. That's on the right of this chart. We translated the study measurements to one of the 3 range health attributes. That's along the top. Data was transformed into a unitless % change, so we could apply these to our baseline health data. That's on the y-axis. We also noted the number of years since practices were first applied for each treatment. That's along the x-axis. We ended up setting a cutoff point of 5 years since there were a few long-term studies that we reviewed for these practices. But this allows us to recognize that practice effects might not happen in the first year or even the second year. It might take longer for us to see a change from implementing the practices. So first, you'll note the incredible diversity of outcomes on these charts. Each dot is a value recorded in the database, so ranging from more than negative 100% change to more than 100% change. But overall, practices tended to have positive influences on health attributes. Many effects increased over time as well. So for example, brush management's effect on biotic integrity tended to start negative, but ended up positive in year 2 and beyond. The literature did record some detrimental effects, which we felt were very important to include. So for example, there weren't many data points for it, but the literature that we reviewed found negative effects from herbaceous weed control on soil and site stability. And this is usually due to the studies finding increased erosion from that practice. So we used all this data to derive an average curve of effects, which you'll see in those green lines on the charts. And these are how we describe how each practice affects the baseline health index. So the last part of the framework is to combine all the pieces we've just described together to estimate monetary benefits of these practices to communities. This chart kind of shows how that workflow goes for NRCS data. So for each year, starting in 2011, in each MLRA, we determine what practices were applied on contracts that year, where they're being applied and on how many acres, what the land health was in the previous year, how much it's changing, and the ecosystem service value from that change. Each year, the health index is updated based on what happened in the last year. And then we also include those residual effects for up to 5 years. We continue all the way through 2020, including those residual effects from that last year as well. So before I get to the results, I want to share some of the deliverables that came out of this project. So we have a full PDF report that we released last month. You can find it both on the CEAP Grazing Lands website here and on Earth Economics website. We submitted a manuscript to the Journal of Soil and Water Conservation that's awaiting review. On Earth Economics website, we also have an interactive dashboard for this report, as well as for our previous report on the Central Great Plains. And finally, you can actually access the valuation data set I showed earlier through this DOI link here. So first, I'll go over the scale of conservation being done in LRRD, and note again that these slides all show annual averages over the time periods that we assessed. So on average, NRCS implemented almost 800 contracts each year from 2011 to 2020, treating 1.7 million acres each year, or about 1.8% of non-federal rangelands in LRRD. For these 3 practices, BLM implemented 105 treatments over 83,000 acres, which is less than 0.1% of their rangeland area, according to GIS. These maps show the average % change to the rangeland health indices on contracts in each MLRA. across both non-federal and BLM rangeland. So soil and site stability decreased on treated acres on average, and we think this is likely due to that herbaceous weed treatment practice, where literature was showing it has negative effects on soil and site stability. But both hydrologic function and biotic integrity improved on contracts all across all MLRAs. You can find these maps on the website link that I shared earlier. And when you use those interactive web pages, you can cycle through different years, MLRAs, different practices, and ecosystem service combinations. And you can see where within the land resource region, the practices applied have had the greatest effect. These results too are a combination of the number of contracts certified as well as the land health and type of ecosystem. So darker areas of the map don't necessarily line up with where the most contracts are. So for example, contracts in MLRAs that have less departure from reference conditions might see less change since they already started high on that health index scale. So to the ecosystem service values, LRRD is a huge area. It's hundreds of millions of acres, and we find that it provides billions in ecosystem service benefits each year. We saw that NRCS spends about 13 million each year in financial assistance, and we find that the return is a range between 8 million to 21 million in ecosystem service benefits. Since this study is so high level, I think it's more important to focus on the overall scale of these numbers, and especially the fact that we can say NRCS is supporting at least as much as they spend in financial assistance to improve ecosystem services, if even a little more on average. And it doesn't count all of the practices and benefits we weren't able to include as well. But with only about 1% of the land being treated by these three practices relative to the baseline ESV of the area, benefits are only improving by less than 1%. This may be a factor that, according to the NRI data, these rangelands are already pretty healthy. But keep in mind that these conservation practices not only improve health, but maintain it too. So that 13 million in cost sharing is also helping maintain all those billions of dollars that we're getting in ESV benefits. BLM rangelands also have a similar story, although we don't have any expenditure data to compare it to. So scaling it down on a per treated acre basis, here's the table that Erin showed again. It's showing the ecosystem service value returned for every acre treated by one of these practices. So each time we do brush management, we can expect $5 to $14 in ecosystem service benefits on average. And just last, we recognize that our framework has several assumptions, so it's important to test how these could affect overall outcomes. Here we focused mostly on how our benefit transfer values affect the total outcome of those ecosystem service benefits. So here you can see which values on which land cover types produce the greatest non-market value changes in our study area. So this is a result from the dollar per acre per year values themselves, but also the acreage they were implemented on and the health of the areas they were implemented on. So we can see those high ranges in forests didn't have as much impact on the total results due to the low acreage of forests in the study area. So to wrap up, I'll loop back to Dr. Lien's introduction and just say that estimating the value of nature while working with producers to conserve rangelands is really cutting edge. It blends many different sciences together, and it's ultimately about bridging that gap. It shows how cost-effective these practices really are, so the public understands all the benefits they enjoy from conservation actions on productive rangelands, in addition to the benefits that accrue to producers. But again, I also want to emphasize that these are conservative estimates. There are so many services that we weren't able to value, and we hope that this project can serve as inspiration to primary researchers to fill in many of those gaps that we encountered, from the types of biophysical outcomes from practices to ecosystem service values provided by rangelands, at least in the economic literature, we find that these types of systems are relatively understudied. And finally, just to say that looking at non-market values is only one way that we can characterize value. These services also support the ranching community. Some of these services do accrue benefits to the producers themselves through cost savings and supporting income generation. And spending by ranchers or people coming to recreate on rangelands also supports local economies and jobs. So where we looked at one aspect of rangeland ecosystem service value, but it's only a piece of the broader set of benefits that rangelands do provide. So finally, I just want to thank everyone for joining us. And Carrie Ann, I'm going to pass it back to you for the Q&A.
Great. Thank you so much, Angela. Thank you also, Dr. Lien. Those presentations were great. We had a couple questions that came in ahead of time from people that couldn't join us today. But if you have questions that you would like to have answered, we have about 5 minutes or so. I'll start with the ones that were sent in ahead of time, but please put your questions in the chat and we'll get to them. So either Angela or Aaron, you can choose who'd like to answer this question. But the first question is, can we take these dollar values for these 3 conservation practices and make any predictions of valuations for other land resource regions such as LRB or LRE, which both abut LRD?
I can go first. I think we set up this data set specifically for LRRD, so I would not recommend transferring them to other LRRs at this time. I think we use different data sets both for this iteration and the previous iteration. So it's important to create the data set specifically for the LRR that you're studying.
Yeah, and I'll just add to that, the benefit transfer method is a fairly durable method as far as being able to use in different places, but it needs to be calibrated to the specific questions that you're asking. So you would need to look carefully at the landscape that you're transferring those values from and to. And so that with the different LR, you would want to kind of carefully evaluate those studies to make sure that they are providing you with the information that you really need to do the valuation in a different environment.
Great, thanks. I'll touch upon something that Bob Gillespie is asking. Bob's asking if the presentation slides could be shared in the chat or at least the references to the websites for the data and other information. And then thanks, Creech. I just noticed that you answered him. Thanks for that. And then Brian, who's one of our guests, asked, is there an active market for ecosystem services? Is the NRCS transacting with landowners at the prices discussed in this presentation? I'll let Dr. Lien answer the first part of the question. Is there an active market for ecosystem services?
That's actually a little bit more complicated of a question than you might anticipate. In general, no, but there are some voluntary markets out there for carbon sequestration, for example, and carbon credits or some other things. There are some regulatory markets for wildlife habitat for endangered species with the Fish and Wildlife Service, for example. And so there are some examples of ecosystem markets out there, but there are not many, and many of them are voluntary as opposed to any sort of regulatory type market. The other question that this raises, especially with NRCS practices, is a question about something that we call additionality in ecosystem markets. So markets prefer conservation actions that were taken specifically for the purpose of generating ecosystem service credits for sale. And so if NRCS is funding a conservation practice, that may result in the ecosystem service benefits from those practices not being marketable in a voluntary market, depending on the rules of that market. But that doesn't mean that the value of those ecosystem services isn't still there, right? So if the question is, can producers derive value from, implementing NRCS conservation practices and then marketing those ecosystem service values? The answer is probably not, but it could be, maybe, depending on the rules of the market that they're looking at. But if the question is the value there, it certainly is there.
Great. Thanks, Doc. Thanks, Aaron. I'm going to go ahead and answer one of the new questions that came in is, where is the study published? So this REAP report that Angela and Dr. Lien presented on is both on the NRCS CEAP Grazing Lands page. The report link is part of the resources today. And then also, as Angela mentioned, you can go to the Earth Economics page and not only see this report, but also the interactive website for the data. So Jim, we can make sure we get, if you have any issues finding the link, please let us know and we'll help you with that. I think we have time for one more question. So I'm going to go ahead and go back to one of the ones that was sent in to us ahead of time. Now that you have this framework, how hard would it be to add more conservation practices, data for LRRD, for example? Could you add in data, for example, for watering facilities or livestock pipeline?
Yeah, I think the limiting factor to this project really is going back and reviewing all of that literature. So both for the ESV and also for that core database, the core database was kind of Carrie Ann's work there. She spent many hours reviewing those papers. So it's not that it would be hard, it's just that it would take a significant effort, I think, to add multiple practices. And yeah.
Great. And then we have a comment slash input from Jonas Feinstein. He asks, the prospect of having support to expand this into forested landscapes is very exciting. How would this best be achieved? He's thinking of, their source water protection, RCPPs, and other efforts are directly tied to forests.
Yeah, I can start by taking that, and Angela can follow up. But yeah, certainly lots of potential in forested landscapes. And in some ways, we know more about the ecosystem service values generated by forest landscapes, especially for things like source water protection. And we have many examples to look to. So for this economic valuation approach, I think you would be able to do that, what we've done here, using benefit transfer in a pretty straightforward way with many watersheds, because we have examples, Denver water, for example, Salt Lake City, the Upper Delaware watershed, the Boston watersheds. So there's many examples of where forest ecosystems have been linked to source water protection and other water quality benefits. And so doing that work, I think, is very feasible. There's also been a great deal of work on nutrients and conservation practices with NRCS practices and outcomes in Midwestern and Chesapeake Bay ecosystems. And so we have a lot of work already that's taken place in those more row crop agriculture-based systems.
Great. Thanks, Aaron. I'm going to go ahead and pass it back to Laura. We're running near the end of the presentation. Thank you so much again, Dr. Lien and Angela Fletcher, to both of you for your presentations today. And with that, I'll pass it to Laura. Thanks again.
Thank you, Carrie Ann, and thank you so much, Angela and Aaron, for your time today. I really enjoyed that presentation. And judging by the engagement in the Q&A, I believe our audience did as well. So thank you for all your questions. A huge thank you also to Clint Evans for his opening remarks, and again to Carrie Ann and others with the Conservation Effects Assessment Project for the collaboration on this effort. Once again, please visit the Conservation Outcomes webinar series webpage to access a recording of this webinar, as well as the presentation slides. Both will be available in mid-March. A sign-up link to receive Conservation Outcomes GovDelivery email messages is currently available on this webpage, along with additional resources from today's presentation. If you're curious about additional NRCS work and to inform voluntary conservation outcomes for grazing land, I encourage you to visit the Conservation Effects Assessment Project Grazing Land Assessments webpage. That URL is also available via the chat. And finally, I wanted to highlight that our series of the net for 2024 are available on the Conservation Outcomes webinar page as well. On our next one, we'll discuss the effects of cover crops on grassland breeding birds. And with that, I wanted to thank you all for joining us today, and hopefully we'll see you again in April for our next webinar.